Today, we want to practice using the chain rule, even though we just barely learned about the chain rule, and all we really have for derivatives is the derivative of x to the n is nx to the n minus 1. Multiply by the exponent, subtract 1 from the exponent. So, the chain rules for finding the derivative of a composition of functions. We usually separate this composition as an inside and an outside function. So our chain rule can be stated in words by saying we take the derivative of the outside with respect to the inside, that is, leaving the inside as it is, then multiply by the derivative of the inside. Let's practice. Pause the video here and find the derivative using the chain rule of these 6 functions, or I should say, find these 6 derivatives using the chain rule. Welcome back. Let's take a look at this first one. It's just an x to the 4th, but we got to notice that the chain rule is always in effect. So we know that the derivative is going to be 4x to the 3rd. That's the derivative with respect to the inside, which is just x. So the derivative of a something to the 4th is 4 times that thing to the 3rd. But in this case, that thing just happens to be an x. The chain rule is always in effect, but the derivative of the inside here is just 1, because the derivative of x is 1. So we don't bother writing that, but secretly we could be thinking it, times the derivative of the inside, which is 1. But we would just leave this as 4x to the 3rd. And that'll be it. So in problem 2, or derivative 2, we've got some small change to the inside. Instead of just x to the 4th, we have 5x to the 3rd to the 4th. So let's see how we read this problem. We want the derivative with respect to x of 5x to the 3rd is going to be the inside, and it is inside a 4th power function. So we're reading this as something to the 4th power. And I want a little excessive with the parentheses there. The derivative of something to the 4th power is 4 times that thing to the 3rd power, then times the derivative of that thing. In this case, that thing is 5x to the 3rd. And the derivative of the 5x to the 3rd is 15x squared. If there's more stuff going on in your chain rule, like if this x was not just an x, then I would multiply by the derivative of the inside yet again. So here is just our raw derivative before we bother simplifying stuff, but we could presumably just simplify that with a little bit of algebra. In the third one, I've still got a 4th power. So in problem number 3, I want the derivative of 5x cubed plus 7x to the 4th power. So my outside function is still to the 4th. It's something to the 4th power. In this case, our something is 5x cubed plus 7x. The derivative of something to the 4th power is 4 times that thing to the 3rd power. So I'm going to have 4 times that thing to the 3rd power times the derivative of that thing. In this case, that thing is a 5x to the 3rd plus 7x. And the derivative of that thing is 15x squared plus 7. Presumably, we could just hit this with the algebra stick for a little bit until we get a simplified form of the answer. But I kind of like this form because I can see very clearly what happened in building this derivative. I can see the 4th thing to the 3rd and the derivative of the thing. So I kind of like this. I kind of prefer this. In the same way, I kind of prefer this up here, all expanded out. But this was we got a monomial up here, and so sometimes we would want to simplify our monomials. It's not that much work. Here, I'd have to cube this binomial and then multiply by another binomial. That seems like a lot of work. So presumably we could do that. So prosecution will stipulate that defense can easily pull that algebra off. In problem 4, I've altered what the outside function is. In this case, we'll notice that problem 4, 5, and 6 are all 5x to the third, except for this last one where I messed up and I intended for this to be a 5x to the third. If you already did 5x to the fourth, then instead of 20 something to the third, you'll have 15 something squared. So in problem number 4, I want the derivative. Now our outside function is 5 times thing to the third power. So 5 times thing to the third power. And in this case, the thing is just an x. The derivative of 5 times something to the third power is 15 times that thing to the second power. So I get 15 times that thing to the second power. Then we multiply by the derivative of that thing, which in this case is just 1 again, because the derivative of x is just 1. So we wouldn't write all of that. We would barely even think all that. We just go with 15x squared and say that's one of our old problems. We know how to deal with that. In problem 5 and 6, I replace the inside. So in problem 5, I have the derivative with respect to x of 5 times x to the fourth to the third power. But there's the structure, 5 times something to the third power. In this case, that something is x to the fourth. So the derivative, since we're practicing the chain rule, rather than saying that this is 5x to the 7th, or 5x to the 12th, that's the other reason I don't want to do that much algebra. I'm going to say the derivative of 5 times something to the third power is 15 times that thing to the second power, where that thing is an x to the fourth. Then we'll multiply by the derivative of that thing, which in this case is a 4x to the third. We could simplify this, but writing it this way clearly shows that we are using the chain rule, and we have used the chain rule properly. If we keep going, and without writing this down, then we might make a mistake. Maybe 15 times 4 suddenly in our minds is 80 and not 60, like it's supposed to be. But we can see the 60 times, here's x to the 8th times x to the 3rd is an x to the 11th. If we had multiplied this, x to the 4th to the 3rd, that's going to be an x to the 12th. 12 times 5 is 60, x to the 11th. So everything matches up. Always good when everything matches up. I was supposed to use a 5 something to the third. So I'll just do that again. 5 times stuff to the third. That's our base. And we have a different inside, an x to the 4th minus 7x to the negative 2. If we can write sums of power functions, then let's write sums of power functions. Our derivative of the outside is still the same because we're still using the 15 something to the third now that I've changed it. And I have 15 times that thing to the second power for my derivative, where that thing is x squared to the 4th minus 7x to the negative 2. Chain rule says multiply by the derivative of the inside, and the derivative of the inside here is 4x to the 3rd plus 14x to the negative 3. Once again, we could simplify this with some algebra, but this stage right here is great for practice because we can clearly see the chain rule in effect. The derivative of the outside with respect to the inside times the derivative of the inside. But we can do a little bit of algebra, then we can check our answers on wolframalpha.com and be confident that everything worked out just fine. So there's some practice with the chain rule. We got to remember that the chain rule is always in effect, even when the inside is just x, because the derivative of x is 1. We just kind of don't write that one very often, but the chain rule is always in effect. That's going to do it for today. We'll see you all on tomorrow. Everybody have a good day, and thanks for playing.